Persons of trigonometry, good evening.
Hello.
Thanks for taking time out of your day to sit here in the evening with me and talk about trigonometry. So, Will, are you suffering? Stefan, are you suffering?
What was that?
Are you suffering? You're here learning math for the next 2 hours. Is this suffering?
Yeah, I think all my brains leaked out.
I'm playing with triangles for 3 months. We're all suffering.
Yeah. Yeah, I get that. I get that. I always feel like my job is to inspire you to some extent, but also to have some realistic understanding that you're not in here because you want to be. You're in here because some degree requirement puts you here. So I do actually feel, which is probably unusual for a teacher, that my primary job is actually to help you get this the heck over with.
I actually did similar math back in high school, but that was 20 years ago or
Another
something.
life, yeah. That was another guy.
Mhm.
You really lose it if you don't use it. I've
Yeah.
placed lower than a class I'd had before. So.
Well, when my job before, I used a lot of math, but it wasn't like this. I mean, there's some of it was, but it was more, I guess, algebra and geometry.
Yeah, this is pretty theoretical stuff. You're pretty far out in the universe here. What's the furthest you went, Angel, with math, and how long ago ish?
Oh, sorry, hold on. I don't even remember. I think it was applied algebra maybe about 7 years ago. Yeah.
How about you, Nicholas?
This class about a year and a half ago.
Okay, right on. So to what extent does this feel like brand new, like you were never here, versus, oh, it's kind of there?
I remember some of it, bits and pieces, mostly useless crap. Because I was working in a warehouse for that 1.5 years and none of it applied.
Yeah, you didn't use it that much at all. Yeah, I always kind of feel like when you're learning things like this, it'd be kind of neat to have some outlet for it, to feel like, because most people are willing to learn anything that's required of them, but they just kind of want to know pays off somehow. You don't want to just take it and like pass that requirement. And I don't know, from my perspective as a teacher, I never like it when people say, well, we want people to take Math 112 just because it's hard. And if they can do hard things, then they'll be good at nursing, or whatever the case may be. I suppose there's some truth in that, because again, it's kind of, from my perspective, it's a little bit weird being a teacher, because I'm not the one that made you be here. You know what I'm saying? Like, it's not my choice. The nursing department doesn't ask me, do you think we should make them take this class? They make all those decisions without us. And then we're sitting here forcing it down your throat, so to speak. So yeah, I feel like let's learn how to get this over with. I do hope, I hope there's a few of you essentially that are lucky enough, if you will, to be taking this knowing they're actually going to need it for something. And like I said, I'm teaching engineering, and these are things we're using all the time in engineering. And so at least you feel like, okay, I'm glad I took that class. It actually went for something. So, but at very least, I was actually teasing my dentist a week ago being there, because I said that's what I always use as an illustration. Coming to math class is like going to the dentist. I mean, I'm here of my own will. I want to be here because I'd like some clean teeth, but this sucks. And so can you make this as easy as possible and get done really fast? Yeah. Well, good. One way or another, you're only a week away, week and a half from knocking this out. Actually a week, because today a week from now is your last class, right? So cool. So we do have a test on Friday over chapter 8. I guess I should, now that I'm thinking about it, I probably should say something about that really quick. So maybe I will. I wasn't kind of just occurred to me that I should probably talk about that. So let me think about this. Where would that be? Yeah. So at the bottom of chapter 8, notice test theory review sections, everything we've done since the last test, 7.2 through tonight. So your test is going to look very similar to this. Because this class is structured to be online, I'm essentially choosing the same types of questions for your test. So you want to spend some time in here looking over this test review. Again, there's some good help in here. You're more than welcome to email me, send me a message inside my open math and say, hey, can we have a quick Zoom, about question number 10? Because I still kind of think I'm terrible at that. And I'd love to do that. Or even if you want to stay after class tonight, because you've already done this a little bit, and talk about any of these types of questions. You would have done all of these in your assignment. So if you're really working at your assignment and making sense of it, but there's a difference between surviving a question because you watch this little video link and you notice these, in my opinion, these are a little too helpful. From your position as a student, when you read a question like this that's very complicated and you think, I have no idea what to do, then you click on the video and the guy's doing a question that's almost the same. And so you can find yourself saying, okay, I'll just do what he did and she did, and then I got the right answers, but there's a big difference between that and actually understanding it so that you think, I see what's going on here. Again, I insulted questions like this earlier by saying, you're never going to do this in any class. Like even as an engineer teacher, you're never going to use this skill. As I mentioned, really these identities are just there to help you solve problems that come up in random situations. And we're going to use some of those identities tonight. But anyway, all that to say, practice this stuff. I mean, if your goal is just to get this stuff over with, there's way more questions in here that are in your assignment than on your test. And so I'm trying to give you enough practice in here to be good on the test. And you should recognize some of these questions because these review questions were questions in your assignment. In your assignments since 7.2. So spend some time in this and feel free to fire me off an email. And so now we're down in these last few questions talking about vectors and so forth. So yeah, feel free to stay after if you want to look any of that over, but just making sure you kind of know that's in there so that you can steal some knowledge and ace this test. It'll be just like last time. It's set up to pop open to you Friday. Let's double check that just since we're all talking here and we're all friends and all. Let's see, where would I have put that? I would have put that in the folder I called tests. Notice chapter 7 and 8 test opens up Friday, 3/19, bam, that's 2 days from now, 8 o'clock in the morning. It's open till that night. So that's kind of cool for you because you can just figure out any time slot you want to take that thing. While we're in here, let's go into settings and see. I'm not sure if I can find this fast enough. Time limit, 65 minutes. I don't know if I like that. Let's make it 75 minutes. Now you all know. So you got 75 minutes. Once you open this, you got 75 minutes before you're sending it back to me. And so that feels good. That feels like an hour and 15 minutes, as long as I'm careful to make sure, the test is a lot smaller than what we just practiced. And maybe I'll even tack on 5 more minutes. So you kind of have time to scan it and send it to me. So y'all feel good about that process? Anything you want to say about that? Again, I feel like
Hopefully it goes better than the last one.
and I'm a big partial credit person in the sense that if I can discern, because your work is clear, the difference between a stupid mistake, not meaning you're stupid, but just 2 + 3 is 6, that kind of a mistake. If I can discern that your mistake is the kind of thing that when we look at it, you're going to go, oh, what an idiot, what was I thinking? Then I'm not taking very many points off for that question. So make sure your work is clear, because getting a question wrong is not the end of the world if your mistake is silly. And again, just test taking advice. I'd recommend going through the entire test, doing every single question. If you see one that you're kind of like, I don't really like this one, then skip it and move on. So you can kind of feel like, okay, look at that. You know, I got 80 minutes and I've only used 40. And now I got these 2 or 3 questions that are not so hot. 2 of them I didn't try and 1 of them I got wrong. And so then you go back and, you know, slowly tackle those. The other thing I would say is if you got, you know, an organized piece of paper and you do a bunch of work on it, don't throw it away. Like I'd rather just see you put a big X through it so that I can still see all of it. And then go on, because when you put an X through it, you're saying this is not my answer, and then you go on. But see, I can still look back at that and kind of see, you know, what happened there? Why did it not work? And, you know, I even look at the stuff you throw away and, you know, that tells me, do you understand this stuff, you know, well enough that I can give you some points and help you get the heck out of here. So your thought process is really important about this stuff. And a lot of times I find if I have time one-on-one with a student, and I'm happy to do this with any of you, like after a test, even a test that somebody got like a C on, say you got 72% and you're like, that stinks. A lot of times in less than 10 minutes, we can have a one-on-one conversation that leaves you thinking, wow, I totally understand that now. Well, if you can understand what you didn't understand in 10 minutes, you know a lot. You know, and so you'll always be frustrated based on mistakes you would have made, but I wish there was a way that tests didn't have to be that final. So ideally, we're having that conversation about the review before the test. That's kind of the point. So please ring my bell, rattle my chain before the test if you feel like you need to. Okay. Let's do one other cool question, and then we're going to talk about this thing you've never heard of called the dot product, which is a really neat kind of a little tool. So I just want to give you one more kind of cool vector problem that I actually stole this question directly from my engineering class. So I'm actually teaching this question to engineers, which is why it's all made up professional style, except I want to make one modification. So you got this force up here. So again, think of this like a bridge. Here's a bridge and there's one joint on the bridge right there. And you have cables or pipes connected to it. And notice this thing, if you will, is being pulled on in 3 different directions. F1, notice F1 is 234. I think I'll change this to pounds. The metric version of pounds is newtons. But just so that it feels a little more comfortable to you in a class like this, let's call it pounds. And so that's pulling, and notice it's at a 27-degree angle, while 27 degrees from vertical. So it's pulling over there at 234 pounds. And notice that's the biggest pull there is. Notice that vector is also drawn longer. So these are actually drawn to scale because I used AutoCAD, which I showed you a little bit of. And then force 2, I might as well write that in there. Force 2 is pulling at 189 pounds. And so it's a little bit shorter. And again, 47 degrees. And then force 3 is the smallest at 148 degrees, 148 pounds, I mean. 77 degrees from vertical. And so my question to you is, where do you think that's going to go as a result of all of those pulling on it? Is it going to go left or right? Is it going to go up or down? Well, let's start with left or right. What do you think? Is it going to go left or right?
Left.
Why do you say left? I think so too, Stefan.
There's more I guess weight pulling on that direction.
Yeah. Like the force 2 and force 1 are both trying to get it to go left, and there's only one going right. And so maybe it's going to go left. Now, the disadvantage of this, and we're going to talk about this today, would you agree that that is all you're getting out of force 1 with respect to going left? Does that make sense to you all? This is why we've been breaking these things into X's and Y's. So at 234 pounds, not as much of it is going left. And then notice the 189, that's how much you're getting out of 189. Notice the force 3, you're almost getting all of it. Does that make sense? Like it's pulling in the correct direction. But overall, now that I draw this, I would agree with Stefan for sure, because wouldn't you agree that the sum, if I take this vector and move it, actually, I'll try to actually move it and see what happens. Maybe, I don't think that's going to work. Yeah, it kind of worked. Doesn't it look like the sum of those two on the left is bigger than the right? So I think we can say for sure now it really is going left. Do you agree with that? You tracking with the concept of what a vector can do? So, okay, that's kind of cool. What about up or down? up, up or down? What do you think? Is it going to go up or down as a result of this?
I think it's pretty close, but I think it'd go up.
Yeah, it is close. I agree. Do you agree this is kind of tougher to call? Anybody agree or disagree with Nicholas on this? I don't know. Like, I'm not sure. I think he's right. I think it's so close. It's too close to call. To Nicholas's point, though, 234 is going up, and that is a really big vector. And not only that, it's going close to straight up. So again, we could kind of do the same thing. Would you agree that this, if I connected it across, that's how much is going up, and that is how much is going down because of that vector. This is how much is going down as a result of that one. Yeah, I'd say he's right now, wouldn't you? So I actually think this thing really is going left and up. That's what it's going to do. The result of this is left and up. I think that's true. Well, I'm going to make this problem slightly different. An engineer's job is actually to not let that joint move. And so let's do this. I'm going to go in here and throw in a fourth force 4. And I don't know what size force 4 is. And I also don't even know where it's going to go. So I'm going to purposely draw it randomly and just say, well, we don't have any of them in the first quadrant. So I'm going to throw it in right there, force 4. And I don't know what angle to say it's at. Do you understand that? I don't know what angle to put it at. And I don't know how strong force 4 is going to be. And so the question is really force 4 equals how many pounds? And theta is, well, what size? But does it make sense I have to fix both vertical and horizontal to get that not to move? To, in engineering language, make that static or not move, not moving. I'd like that thing not to move. And so the question is, where is force 4 and how hard? And so an engineer would attach one more cable to this to make it not move. And so let's see if we can use what we've been doing lately to figure this out. That's kind of a cool question. Again, that's not the question that was asked here. I'm sort of answering, I'm making up my own question. And so I'm totally guessing about force 4 being in the fourth quadrant. Now, I'm going to erase this, but given that we decided the overall force here is going left and up, does it make sense that might be the resultant? Isn't that left and up? And so does it make sense if that's left and up to fix it, we're actually going to have to be down here? I'm actually pretty sure force 4 should be down there in the fourth quadrant. Do you see the logic in that? I have to pull in the opposite direction. So if I wanted to be smart here, I would just stick force 4 down there. But let's pretend we don't know. And so we just threw it in there randomly because it's hard to tell. So we just threw it in there somewhere. And let's see what happens as a result of this. Well, are you convinced that, man, that's complicated? But the way we just checked this and the way we've been doing these things is to kind of see what's happening in the X and see what's happening in the Y. And so let's see if we can get the sum. You probably haven't seen this symbol before. This is a mathematical symbol for sum. Let's see if we can get all the sum of the forces in the X direction to be equal to 0. That's what we got to have to get it to be static, right? And the cool thing is we don't have to make this so complicated. We can just look at one thing at a time. And that's exactly what we just did a minute ago in order to conclude, I think correctly, that the result of those 3 forces is left and up. So ding, ding. Let's go get it. So what do we got? Would you agree that since force 1 is 27 degrees here, that a safer thing to call that angle, since we always measure from 0 over here, would be to go all the way to here? And since this part of it is 90, and then it goes on 27 more, that'd be 117 degrees. Do you agree that the angle for force 1 is really 117? And so if I do that, I can say, well, didn't we use cosine for x's? So I can say, okay, well, if I take 234 times the cosine of 117, that's going to be the x coordinate for force 1. You okay with that from our discussion before? Again, interrupt immediately. Don't raise your hand, like start talking. Like I already know this. I'm not talking to hear myself talk. I want you to understand it. And then if I add to that force 2, notice what its angle is. Well, it would be from here to here would be 180, wouldn't it? And then it's another 47. So I guess that'd be 227. Is that right? So this is 227 degrees. That's what you would call it. So then I can say, okay, great. Then take 189 times the cosine of 227 degrees. And then lastly, well, almost lastly, what about force 3? Well, notice because this is 77, does it make sense this angle would be 13, since 13 and 77 is 90 degrees? But that's not 13. What would I call that if I want to go that direction? Somebody blurt it out.
Negative 13.
Yeah, that's exactly right. Negative 13. Now you're also welcome to rename it, whatever that is, 347. You can name it the positive version if you want to, but that's just more work. There's nothing wrong with saying that angle is negative 13. So those are all the x coordinates. Now, notice I guessed, and again, we agree we guessed incorrectly that force 4 is sitting there in the first quadrant. And so, and notice its angle theta is correct right now. Like theta is this angle right here. So I could finally say plus force 4, which I don't know, times the cosine of theta, which I don't know, would have to be equal to 0. Do you agree that all of that would have to be true? That whole mess has to add up to 0 to get it not to move left and right. Now, as an algebra student, you should be not happy with this equation, even angry. Why? Because it's got two unknowns. It's an equation with two unknowns. You can't solve equations with two unknowns. So although that's a true statement, you can't just come in here and say, well, I think I'll make theta 15 degrees and then I'll solve from there. Because remember, you got to get it to work for y too. And so I got an equation with two unknowns. And so I'm not happy right now, but can't we go do this? Well, do it again for, can't we do this again for the forces in the y direction? So I'm going to make myself a little room here. And let's now tackle the y direction and see what happens. Like this is one of the reasons I'm showing you this, as well as helping you practice and understand the concept of what vectors can do, is this is how, if you know the language of algebra, you can actually get stuff done that you just can't do mentally. You can't just stare at this and get the answer to this. And so what's the sum of the forces in the y direction? Well, I also need that to be 0. So now watch how fast this goes. All I have to do is go back and look at what I just did before, except for say 234 times the sine of 117 plus 189 times the sine of 227 plus 148 times the sine of negative 13 plus force 4 times the sine of theta. That also needs to be 0, right? Now, although I'm not happy, I'm not as mad as I was before. Why is this okay now? Why is it like, oh, okay, I think I can actually solve this? Why is this not so bad now? What do I have? Yes, I have two unknowns, but you also now have two equations. I have two equations and two unknowns. Well, I can solve that. Again, that's something you should understand. Now, you've never seen two equations, two unknowns be created in such a practical way, perhaps, or like a reason to solve two equations, two unknowns. You sat in a 111 class where somebody just made up two random stupid equations and said, find out where they cross into each other. And you're like, why would anybody ever do that? Well, here's a place where you need to be able to do that. And I would wonder, if I give you a minute here, could you solve that yourself? Like, wade into it. Your first response should be, I'm not sure. I don't know. But notice there's a whole bunch of stuff like this whole statement right here is just one big number, right? Can't you just plug all that into your calculator and turn it into a decimal? And the same thing is true for this down here. So like start, let me just give you a few minutes to see if you can solve this yourself. And let's see what results from that. See if any wonderful things happen, and maybe you'll get stuck and then I'll earn my money by teaching you something. Make sure your calculator is in degree mode. I can't remember. I think in this section we mostly been in degree mode, but since I gave you the angles and degrees. I just made this up, so I don't know the answer either. I'm doing it with you. Just to make sure you or I didn't push a calculator button wrong. I don't care how you round this. I just am choosing to round it to 2 decimal places. Did you get this? Again, I'm checking you as much as me here. I see a couple of you nodding.
I got a different number for the other one. I got 38.439.
For force Y?
Yes.
I'm checking what I typed in. Double check what you typed in. Again, this is what's really cool about the graphing calculator. You can say second entry. You all know that? Right above the enter sign, you say second entry, and then your equation pops back up, and then you can go look at it and edit it and not have to retype the whole thing if you screwed it up.
Oh,
Bella,
sevens and nines are different.
That's what I mean right there on the test. I reserve the right to point at your 7 and tease you for not being able to read your own handwriting or whatever, and to say dude and stuff like that. But it's like, with 10 of us here doing this, there's no way all 10 of us aren't going to push some button wrong or not be able to read all our own writing. So thanks for volunteering for this round, Stefan. I appreciate that. I don't know about you, but that doesn't look so good. Like I don't know what to do. Anybody make any progress with this? Anybody have any good ideas on how to solve that?
Okay, at the risk of sounding really dumb, can't you use the inverse of the cosine on the first one to get it to I don't know what I'm trying to say. If you try and solve by using the inverse on that,
Yeah, like couldn't you solve, for instance, the top one for theta? Now, in order to do that, you should know from this class, you'd have to get cosine of theta by itself first by adding 90 and dividing by force 4. But then you could take the inverse cosine and then you'd have theta. That would work. That's a little hard, but it would work. Now, interestingly, I'd like you all to think about this for a second. So if you did what Stefan proposes, you would first add 90.92 to both sides. Then you would divide both sides by force 4. And then you would take the inverse cosine of both sides. And you just solve for theta. Now, why is that good? It's a little terrifying.
wouldn't that tell you what quadrant you're going for though?
It might tell you what quadrant you're going for, but the problem is you don't know what force 4 is.
Check.
Force 4 could be negative, meaning I totally went the wrong direction with it. But you do, to your point, at least know what theta is equal to. And if that's true, couldn't you replace that theta in the second equation with it? And then I would have an equation with only force 4 in it. Now it's a really ugly equation. And we might be able to
That's
solve
how I do. That's how I do things. I find the most painful way to do it, and then go ahead and just bang my head against the wall.
It would be a little easier if you backed up to this stage right here. And instead of trying to solve for theta, if you said, I'm going to solve for force 4, wouldn't that also be true? And so then if I took this and replaced force 4 with that, notice I put it into the second equation because somehow you got to put these equations together. Mathematicians call this substitution because I took what force 4 is equal to in one equation and I replaced it, substituted it into the second equation. Do you see what that accomplishes? Now my force y equation becomes 36.98 plus force 4, which I just decided to replace with 90.92 over the cosine of theta. And that's still multiplied by the sine of theta, right? It's like I'm just replacing it and then equals 0. So I'm not real happy about that because it's got two trig functions. Do you agree with that? However, who sees something cool? Come on, how can I rewrite that? You're multiplying fractions. Sine of theta is a fraction. It's over 1. I multiply fractions straight across. What's true about sine over cosine?
Well, it's tangent, isn't it?
Exactly. Now, as you move on in math, that's the kind of thing that people are going to wish you knew when you left this class. Like, notice how creative that is. Like, would it occur to you? That's the whole point. You spent all these time with these stupid identities, and you should have seen quite a few times that tangent could be written as sine over cosine. And what needs to happen is like a spark of lightning in your brain. It's like, hey, sine over cosine is tangent. Because there's a whole page of those identities. And so, you know, very least to say sine over cosine was maybe that's possible to replace with something. And you look at your identity sheet, maybe you eventually find it. But do you see how cool that is? Because doesn't this then become, and now for the first time, bam, I'm pretty happy because that's how you solve trig equations is by getting one trig function by itself and then doing what Stefan said, which is trying to get tangent alone and then taking inverse tangent. Like this is going to allow us to find the angle. give you a second to pass me up and get this answer from here. But again, honestly, I would be very impressed if any of you knew algebra enough to be able to do that, because that's not obvious. Like, you know, you just got to play around with stuff. But I can see this is going to work now. I'm going to get theta. I'm going to actually figure out what theta is. This is very exciting. So of course, I hope you subtracted 36.98 from both sides. You're on your way to getting theta by itself. And then you divided both sides. Yeah, you're ahead of me here, I hope. Divided both sides by that. And then you said, bam, I'm done. Theta is equal to the inverse tangent of negative 36.98 divided by 90.92. Your calculator tells you what that is. Oh man, this is sweet.
It gave me negative 22, which I feel is wrong.
My calculator agreed. Who else said that? Who said they also got negative 22? Sorry,
I did.
Angel, thank you. So again, round it however you want. I got around 22.1. But think back to our original shape. As I said before, didn't we all kind of agree that this thing was going to be left and up? Those three that we knew were going to be left and up. And so if that's true, to make this be zero, wouldn't the one pulling against it have to be down there in the fourth quadrant? What angle should I get to be down in the fourth quadrant? A negative, right? So we just got negative 22 degrees for that. That actually, I'm not surprised. Of course we did, right? It's actually not that surprising. So I think that's correct. Now you may remember from what we've been studying recently, remember inverse tangent is dangerous. Anytime you go inverse sine, inverse cosine, inverse tangent, there's two answers. From my note sheet, which ones do we have to worry about? Well, the ones that were in the second or the third quadrant. Our answer came out in the fourth quadrant. Good, we don't have to worry about it.
Something else I did was wrong then, which is what was screwing me up.
So how am I going to get force 4 then? Because I need to know that too. If I'm an engineer, I need to know what angle to attach the cable, but then I also need to know how much force is going to be on that cable so I can choose a cable strong enough to do it. How am I going to find force 4?
Well, you already have two of the sides there in that tangent, and then just find the hypotenuse of that triangle.
Yeah, you could draw the right triangle. Let me see, would that work? I think that would work. But would you agree we have a couple equations up here now, right? And now that we know theta is negative 22, couldn't I go put that back into either one of those? And then it would leave me with only force 4, and then I could solve force 4. I think Nicholas is right too, but I'm a little concerned about that. I know for sure it'll work if I go back to either one of those. So for no good reason, I'm going to pick this top one. So I got people in my house right now. Can you guys hear them? Is that distracting? It is? I'll fix that. So you guys finish this and tell me what force 4 is, and you all agree on it, and then we'll be done with this problem.
Is this mic working? Is that okay? Cool. That should dampen the sound because their noise probably won't make it to this mic. So somebody tell us, what did you get for Force 4? And let's see if people agree. It's okay to be wrong. It's just not okay to stay wrong.
.13 roughly.
So I just wrote down the first answer I heard. So either confirm his answer or give us another one, and let's just keep going until we all agree. Kate put in the chat she got the same thing, so that's a good sign. It's unlikely that two people made the same mistake and got the same exact wrong answer, right? So that's starting to feel better.
I got the same.
Cool. All right, 3 people got it. So I'm thinking that must be right then. So let's throw a box around it. Bam. So do you understand the power of what that would mean for somebody that designs bridges and so forth? I mean, what that literally means is if you went back to this situation up here and you attached the cable that we described right here and you put it in there at negative 22 degrees and you made sure that its tensile strength wouldn't break in half like this pen just pulled apart. It's not going to break in half at 98 pounds. Then that joint will actually not move. And so good job, engineer. Now the bridge didn't fall down. But notice that's just kind of cool because it created 2 equations, 2 unknowns, and it was not obvious how to solve those. Like, do you see how the skills that you've worked on in this class are involved? Like, it's legit to be able to figure that out. That's not simple. But I would like to show you something just kind of cool real quick. Got to take a picture of those equations. Let me just show you what an engineer would do with this. Engineers get paid to make bridges not fall down, not to know trigonometry. So wasn't our first equation negative 90.92 plus F4. Now, rather than F4, I'm going to say X. So X is F4, and then it was the cosine of trig, the cosine of theta, but I'm going to say cosine of Y just because that's what you're used to seeing for letters. And all of that needs to be equal to 0. I'm going to go in here and change this to degrees, and there's the graph. Now, isn't that kind of fun? Like, that's kind of a cool graph. So that's a crazy graph. And what that shows you is all of the different X's and Y's for which that statement is true. That's what a graph is. Thousands of answers. Every single one of them is an answer. Every point I would go to is an answer to that problem. Okay, fine. Whoa. But, wow. This is not letting me adjust the screen anymore, so this is screwing up my plan. Can't adjust the size. I'll fix it. We'll fix it in a minute. And then the second equation was 36.98 plus F4, which we decided to call X, times the sine of theta, which we decided to call Y. And that also, my friends, needed to be equal to 0. Bam. Now, what I would like to do is be able to zoom in, but since it's kind of giving me fits and I can't just kind of do the old stretcheroo thing, we just found out the answer to this a second ago was, let's see, force 4 was 98. So that was X. And so if I choose something between 90 and say 120 for X, and then Y was the angle, and we got negative 22 for that. So if I choose the Y value to be between negative, I don't know, 30 and 0. Bam. Just solved 2 equations, 2 unknowns, didn't do any math. That's what an engineer would do. They'd use some kind of a piece of software like, this is too important to get wrong. You understand that? In the real world, if you actually need math for something, you can't just be like, oh, sorry, I made a little math mistake, because that's the bridge fell down, right? Like, somebody's got to be the final authority to check the work. And so that's just kind of cool. Number one, that we're actually able to get that algebraically, because that was a pretty challenging equation that we had to solve. But it's actually really cool to think that you can actually cheat to solve this. Isn't that kind of neat? So, you know, here's the 2 graphs. They're both similar looking kinds of graphs, really weird looking graphs. And so it's kind of neat that you can actually solve things by graphing. In the event, and this happens in engineering all the time, in the event that you wrote an equation that's too hard to solve, then you have to know this technique. So you don't get taught this that much in algebra classes, because you're always given problems that you can solve using algebra. And so you're led to believe, if you actually knew your stuff, that somehow you'd be able to solve things. But there's actually lots of equations that you just can't solve. And so graphing is really a cool tool. So I'm not looking for an X and a Y that work for just one of the equations. I need it to work for both. Otherwise, it's not going to balance in the Y direction and in the X. And so that's pretty cool. Again, you're leaving algebra. You're 1 week away from people thinking you know stuff, right? Like, oh yeah, I took a bunch of algebra. And yet, didn't you find with this problem that I just gave you, even though you're at the end of trig, and so you should be pretty good at writing trig expressions, and we had an equation to solve, it's like, that's still pretty tough, isn't it? But I don't know, hope you learned something. That's kind of a cool problem, isn't it? That's what I do when I'm teaching engineering. Now, let's learn one more thing. And I want to show you something kind of cool here. Let's get some graph paper. Bam. Yeah, that'll work. And so there's one other cool thing that sometimes is necessary. And let's see if you can see what this is. And so what I want you to try to do is find the angle between vector v, which I will now tell you is the vector, let's say 1, 4, and vector u, which I will say is -6, how about 5? So the question is, can you draw those 2 vectors? I want to know the angle between them. You don't need to know anything new to do this, but what I'm going to show you today is a really cool shortcut and a formula that's on my formula sheet, but it's really weird looking. But let's first try to do it just with regular SOHCAHTOA. So the vector 1, 4. So that means if I was right here, then if I went right 1 and up 4, I'd be right there. Does that make sense? So of course it does, you say. Stop insulting my intelligence. This is so easy. There's vector v, bam. And then vector u is -6, +5. So if I go -6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, bam, there it is right there. So I'm looking for that angle right there. I think you can find that right now. I'm just going to give you maybe a couple of minutes to think about it. But remember, the way I just graphed those was creating right triangles, right? Like, here's your hint. Didn't I count my way over to the first one by going over 4 or up over 1 and up 4? And this one, didn't I go over 6 and up 5? Like, vectors are connected to right triangles. Like, that's what they are. You don't need to know anything new to get this angle. Just use your trig skills. SOHCAHTOA. Nicholas threw in the chat that he got like 64 degrees. See if you agree with him. I'm laughing because Stefan said I'm old and slow, but I got that as well in the last problem. So more than one way to do this, but just to make sure you're kind of on the right track, if you just want to use pictures, I'm going to use other Greek letters, but does it make sense I could find that angle right there by saying the tangent of alpha is opposite over hypotenuse? I'm sorry, opposite over adjacent, and then I could know that angle. And let's see, let's use phi for this angle. And I could do the same thing over there. I could say the tangent of phi is opposite over adjacent. And then I could know those two angles, but why is it good to know those two angles? Who cares? That's not what I'm after. Why is that awesome?
Subtract them from 180 and you get the one you're looking for.
That's exactly right. That's a straight line. All three of those would add to 180. So if I know those two, I can take them away from 180. Did you see that? Did you? Again, that's not obvious if I just say, what is this? But the point is draw pictures like trig is right triangles and vectors are right triangles. And so if I say the inverse tangent of 5 over 6, second tangent of 5 divided by 6, I got 39.8 degrees. Notice I got rid of the negative signs. Like that 6 was actually negative, but I just drew the picture. Like there's no such thing as a negative length. That's length 6. And so I got alpha's 39.8 degrees. And in the same way, if I say second tangent of 4, I get 75.96. which rounded to 1 decimal place, I guess, is actually 76. And so theta would equal 180 minus 39.8 minus 76. Let's see if Nicholas is right. He knows if he's right now, but we don't. Bam, 64.2. Is that what you got, Nicholas? I can't remember.
Yes, that is what I got.
Sweet. Again, I don't care about rounding. So notice in this case, we took the inverse tangent of both sides, but notice I got rid of all the negative signs. And in this case, I had to subtract the two angles from 180 to get the correct answer. And so that's fine. And the cool thing about what I just showed you is you don't need to know one new thing to do that. Just draw pictures. And you might realize that, the practical side of this is to say, if one ship takes off one way and one ship takes off another way at a certain bearing, then what angle did they take off from each other at? Or if two cables are pulling at in these two XY directions, then what angle are the cables pulling relative to each other? You might be able to see that there's some applications to this, but I guess I won't spend any time talking about this. And that's great. Awesome. Mission accomplished. So we won't do this question, but let's look at a second one now. So let's say I gave you another two angles, another two vectors, and this time I'm not even going to draw them accurately. Actually, I think I will. There's one vector, and here's another vector. What if I wanted to know that angle this time? Again, you should say I can do that in the same exact way. However, I just want you to think about what you'd be doing. Since this apparently is the vector 1, 2, 3, 4, 5, 2, this is the vector 5, 2, and this other one is the vector 2, 3. Agree with that? 2, 3. And again, do you see the value of those little chevron signs? That's saying, hey, this is not the ordered pair 2, 3. That'd just be a dot in space. This is draw an arrow from start to finish to 2, 3. That's the difference. So that's why somebody thought, well, it's kind of like an ordered pair, but it's not an ordered pair. So that's a pretty good idea. I don't have a problem with that. But does it make sense that, well, this time you would have had this angle alpha, and you would have had this angle for phi, but what would you have had to do with those two angles this time? Would you subtract them from 180 to get theta?
What I would do is just make another right triangle, but just do it in the first quadrant. So you'd put a right angle there, and then you would just subtract it from 90.
I wish I could point at the screen.
Yeah, me too.
Yeah, if I was drawn on a whiteboard, then you'd be able to. But can you see from the drawing I just made that phi is your biggest angle, and if you subtracted from it alpha, that would give you theta? Can you see that? So notice like the formula was different this time. Last time it was because we had one vector in the first quadrant and one in the second quadrant. We ended up subtracting them from 180, whereas this time we're subtracting them from each other. And so what this section is, how could I do this a little more quickly? Now, just for the fun of it, I'm going to quickly say second tangent of 2 divided by 5. So I just figured out that alpha was 21.8 degrees. And second tangent of 2 divided by 3, second tangent of 2 divided by 3 is 33.7 degrees. So phi is 33.7 degrees. And so if I subtract those two, 33.7 minus 21.8, don't trust myself for some reason. I get
It would have been
11.9.
3/2, not 2/3, with how you drew that angle.
2, 3. Thank you. You're exactly right. I just got my own problem wrong because it's second tangent of 3/2. You just saved my bacon. Thank you. 56.3 degrees. Everybody understand that mistake? That's an honest mistake, right? Like that's the kind of mistake you might make on the test. And so I'd have to circle it and go, dude, look at your note. Look at your note sheet. By the way, like I drew those vectors correctly. Can you tell by looking at it that theta, that my angle here is not 12 degrees? Like I got 12 degrees a second ago. Can you look at that and go, that's not 12 degrees? Doesn't that look like more of about a third of 90? Doesn't it look like more like it should be more like 30? You know, do you stop and think? Like I might have caught my mistake if I was alone, just because I'm, you know, thinking a little bit. That'd be nice if I was thinking, if I was expecting this stuff to make sense. So I got 34.5 degrees. That looks a little better in the picture, doesn't it? So thanks for keeping us from wasting our time. And so do you see how it's like, it sort of turns out that depends on what quadrant you're in, you know, as to what quadrants your two vectors are in. And so in one sense, I would say you can find the angle between two vectors and you don't need to know anything new. So, you know, mathematicians, though, they love to come up with formulas for things to just save time. Like, is there some way I could just kind of plug those two vectors into a formula and bam, out would pop the answer? And I don't have to think about what quadrants they're in and so forth. You know, we love when algebra can do that, like the quadratic formula, right? Negative b plus or minus the square root of b squared. Like you just throw those numbers in and bam, out pops the answer. You don't have to think about it. That's kind of cool, right? It saves some time. Let me show you something called the dot product. Let's automate this process. Cut out thinking. And again, part of me says that's awesome because I'd rather get the answer right. But the other part of me says, why would I want to cut out thinking? And I don't even need to learn anything new. I can do this right now. So here is the dot product. This is on my note page. Let me see. I'm finding it up because I don't have it memorized. If you take the cosine of the angle that we can't find, we've been trying to find the angle between them, theta, right? If you take that cosine of theta, it turns out that will be equal to the dot product of, I've been using u and v, so I'm going to stick with the same letters. The dot product of u, v, and I got to show you what dot product means because that's kind of a weird deal, divided by the magnitude of u, remember what that means, multiplied by the magnitude of v. If you use this little formula, you'll get it right no matter what quadrant you're in. You just plug the numbers in and bam, out pops the answer. So that's worth something. By using this technique, you gain some things, you lose some things. You don't have to think. You don't have to remember SOHCAHTOA. You don't have to draw pictures. You just plug the numbers in. You can actually get problems right without drawing any pictures. That's kind of cool. So what is a dot product? Notice that is not a multiplication sign. It's like a dot, an open-ended dot. And so that looks like multiplication, and in a sense it kind of is. So it's real simple. Let's just make up a formula for this. So if I said vector u was one number comma another number, right? Could be anything, 2, 3, 6, 8, whatever. And v was another couple of numbers, call it c, call it d. What do you do to get the dot product? You take the x coordinates and multiply them together. And you take the y coordinates and multiply them together. That's why it's called a product, because you're multiplying. And notice those are just normal multiplication signs. That's not a dot, it's just a normal multiplication sign. And then you add them. Now, I don't know if I'll show you this, but that's just a cool mnemonic device. Basically, somebody said, is there some way we can automate this process so that we don't have to always think about, you know, in this quadrant, I subtract from 180. In this quadrant, I subtract from each other. In this quadrant, I add them. In this quadrant, I subtract from 90. Like every problem is different. So mathematicians came up with a way to memorize this. So they called it a dot product, but it's not a thing. Like it's just a memorized process. And then you know what magnitude means. That's the hypotenuse, right? So if I say the magnitude of u, that's the hypotenuse of that triangle. So let's go try to redo. Remember question 1, the first example we did came out 64.2 degrees. And so let's go redo that using this cool little trick. And we're going to get the same answer we got before. Then I'll let you be the judge. You know, is this easier? Is it better? Do you like this better? Let's go see if we can pull this off. So let's see. I'm looking for theta, the angle between these two. And so I say, cool, what do I need? I need the dot product. What's the dot product of vector u dot vector b? So I say, okay, well, that's 1 times -6 plus 4 times 5. That's -6 plus 20, that's 14, right? So there's the dot product, 14. It's a number. That's all it is. It's a number. And what is the magnitude of v? You know this, that's the Pythagorean theorem. So if I take 1 squared and 4 squared and I add them together and square root it, that's the square root of 17. So that's how long the hypotenuse would be, right? That's actually how long the vector is, right? That's the length of that vector line that you drew, isn't it? Just to give you a second to process, like that line right there is the square root of 17 long. Notice the square root of 17 is just a hair bigger than 4. That line would be a little longer than 4. It's just finding the hypotenuse. That's all magnitude means. So if I repeat that, again, please interrupt if you're not happy about something here. If I'm going too fast, even if you just want to say, slow down, let me think for a minute. If I take -6 and square it, and I take 5 and square it, let's see, that'd be 25 and 36. I think that's 61, is that right? All right, I got all the ingredients I need now for my statement up above. I can say, cool, then the cosine of theta would be equal to the dot product, which was 14, divided by the square root of 17 times the square root of 61. No thinking. Just throw stuff into a formula, and this will work no matter what quadrants your two angles are in. That's the genius of this idea. We already know, again, what do we know? We already know the answer to this is 64.2. We did it using our own logic. Just type that whole thing into your calculator, although be careful how you type it. Do you understand that this won't work? That's what you might type in your calculator. Do you understand that won't work? That won't work unless you add those parentheses, because otherwise it's going to be multiplying by the square root of 61, not dividing by it. Or you can just turn that whole thing into a decimal first, but you got to be careful when you have two things on the bottom that are multiplied. Second cosine of 14 divided by the square root of 17. The other thing you can do is type the inverse cosine of 14 divided by the square root of 17 divided by the square root of 61. That's okay too. Do you understand that? I got, whoa, 64.23, same exact answer. That's pretty cool.
What? Ow, I got 61.37.
Double check what you typed in and tell us what you did wrong.
Oh, I typed in 14 instead of 17.
Yeah, so total accident in your case.
I got
I was
the same
hoping
one.
it was something more significant, like my mistake mixing up 2 and 3. That was more of a legitimate mistake. Again, I leave it to you to decide, is this worth it? Part of you should say yes, because you don't have to think, as long as you have the formulas in front of you. But part of you should say, that's really confusing. What is that? Where did that come from? What's a dot product? Like, it's not worth it. I like SOHCAHTOA better. You know, I would feel like in a normal class, like half the people would think it was better and half the people would think it was worse. But can you appreciate, for computer type nerds, does it make sense? You could actually write a formula in a computer that would just accept, I guess it would just have to accept 1, 2, 3, 4 numbers, and then boom, it just spits out the answer. That'd be kind of cool if I could just type 4 numbers in. Understand, that's the world you live in. Like, I was just down at the bank getting a loan, and in the end, there's like a few basic numbers you type in. How much is the loan? What's the interest rate right now? And how long are you going to take to pay it off? And you type those numbers in boxes, and bam, out pops your monthly payment. Like it's magic. You have no idea how it works. In my case, I know how it works, but I don't really care. Like, type the numbers in the boxes and out pops the answer. And so if this was a thing for you, like if you needed to use this all the time, it would be kind of cool just to type those 4 ordered pairs in, or the 2 ordered pairs with 4 numbers, just type them in and have it pop out the answer, because then you're not going to make, you know, important mistakes like I did, getting the numbers upside down, or accidental mistakes like Nicholas did, just writing the wrong number down. Because there's, like, even if you know what you're doing, you can make mistakes, right? So that's the world we live in with respect to algebra. See if you can do this then with this question. Can you take 2, 3, and 5, 2 and repeat this process? Can you get 34.5? Let me just give you a minute to see if you can do that. Notice if you're decent at mental math, you can actually just stare at those 2 vectors and get the dot product in your head. If you got your multiplication tables memorized and you got a kind of a good number mind for numbers. Maybe you can even get the 2 magnitudes in your head, because they're pretty small numbers. Those 2 vectors are pretty small numbers. Can you just write down the dot product? Write down the 2 magnitudes just by looking at them? It's actually really fast.
I mean, we already know the answer, but 34.5.
So from a speed perspective, can you in your head do the dot product? 2 times 5 is 10 plus 3 times 2 is 6. The dot product is 16. Can you do the magnitude in your head? 2 squared is 4, 3 squared is 9, 9 and 4 is 13. So that's the square root of 13. 5 squared is 25, 2 squared is 4, 25 and 4 is 29. Of course, I'm a, do math for a living, but like that's not terrible just to do in your head. And so notice I could actually answer this really fast. So if I just say, okay, cool, what's inverse cosine? Inverse cosine to find theta, inverse cosine of 16 divided by the square root of 13. Whoa, fail. Square root of 13. And the square root of 29. Bam. Yeah, 34.50852299. Notice it's like perfectly accurate because you haven't rounded anything yet. As a side note, totally irrelevant, but from other classes, perhaps you realize, hey, since those are both square roots, the square root of 13 and the square root of 29, you could actually, 13 times 29 is 377. Again, this is a waste of time, but you could rewrite it like that. 16 over the square root of 377, and that'd be okay too. That's just kind of cool to think about. So, I mean, again, the advantage of shortcuts are I could actually answer that question in probably 10 seconds, especially if I practiced it a bunch and it was like what I did for work every day or something. I could actually answer that in 10 seconds. That's kind of cool. No pictures being drawn, no thinking, no subtracting from 180 or subtracting from each other or pushing buttons wrong and so forth. That's kind of cool. Yeah, cool. With respect to the test that you're taking, then, does that note speak to you now? Like, you don't need to memorize this. There's no reason to memorize things like this. At least that's my philosophy. Some teachers think you should, but I just kind of feel like, nah, why? Like, you feel good about that? A lot of your questions in your assignment, more than half of them just pertain to that exact thing that we just did. It's not hard. I would advise you, just because it's kind of cool, to maybe draw a picture of the two vectors though. And, even after you're all done, if you just punch these into the formula, if I had 10 extra minutes on a test, I might actually graph the two vectors and kind of look at them and say, does that angle look right? Does it look like 34 degrees? If you have even more time, bust out a protractor and lay it on there, man. It's like, should be like, oh man, I know them right now. Look at that thing. If you draw with a straight edge, you should be within, you should be able to tell it's perfect just from that alone. That's kind of cool. The next thing I want to show you, and the last thing I want to show you, is this guy. Whoa. So what that weird statement says on the left is the projection of vector V onto vector W. And what the heck is that talking about? So let me give you some insight as to what that is getting at, because this is kind of a cool idea. There we go. That's where we were. So let's take these same two vectors right here. So I'm going to steal this drawing. Bam, copy. Bam, paste. And just to make it match the formula sheet, let's see. V onto W. let's call this one vector V and this one vector W. And let's go get rid of some of this other gobbledygook that is confusing us. And let's talk about what is that even talking about? Like, what is that talking about? Does this make sense to you? If there was a box on the ground and you were pulling it, so you're pulling the box along the ground, or, you know, physicists are always making up dumb questions like this. It's like, why would I pull a box along the ground? I'm hiking 9 miles with my kayak and I'm dragging it along the ground and I'm pulling and pulling and pulling on it. And so if somebody came to help you, who would you want helping you? This person or this person? Person one, person two. Who's helping you more? Do you understand that from vector knowledge?
2.
Do you understand that 2 is, and think about what 2 is actually doing. Does it agree? Does it make sense to you that this is actually what you're actually getting from 2? You're getting the x coordinate of 2. You're not getting 2. So if 2 is pulling at 80 pounds, you might be getting 75 of those pounds actually helping pull the box. Does that make sense? The vertical version is just lifting the box up in the air, which is not helping you. Does that make sense? And what is 1 getting you? That's all you're getting out of 1.
Nowhere fast.
Nowhere fast. 1's not helpful. Thanks for nothing. What are you getting from this person?
Lift.
You're getting nothing. Like, they're not helping you at all. They're just lifting the box up in the air. So this is what projection is. So this brown graph down here that I just drew, this one, that's the projection of vector 1 onto some other vector, because that's actually all you're getting out of them. Does that make sense? And so if you're alone and you're pulling some heavy object, you know, the takeaway from this is don't do that, because you're wasting some of your pull. Of your 80 pounds muscles that you have, only whatever, and we'd have to come up with the angle, right? You knew how to do that. If I told you what angle that was pulling at, then you'd say, well, I can do the 80 times the cosine of that angle, and then I would know how much of my 80 is actually pulling the box down the road. And so this is a big idea in, you know, kind of advanced math. And so that's what projection is. So if this is like, I'll just say vector 4, does it make sense? That's the projection of vector 1 onto vector 4. That's what that language is all about. Again, mathematicians are lazy. They're always trying to find some way to write stuff down that's really easy. But then when you look at it, you're like, what does that mean? But when you say it in English, it kind of like, oh, I see the idea. Then that kind of makes some sense to me. And of course, this blue vector here, that would be the projection of 2 onto vector 4. And so would you agree then that dink, 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 notice that's coming down at 90 degrees right there? That's very important. That right there is the projection of vector V onto vector W. In other words, that's how much V is actually in the direction of W. And so what did the formula say? The formula said the projection of one vector onto the other vector. I don't have this formula memorized. Watch as I turn my head over to look at what it says. It is V dot W. Oh, V dot W. I know what to do with that. I know what a dot product is. And then you're going to take that and divide by vector W. But what do you do with vector W? You find its magnitude. You find out what size it is. But you do something creative. Once you're done with that, you square it. And then you multiply that by vector W. It's quite a mouthful. Let's see what that means. So let's see if we can kind of make sense. What? I don't get it. What is that? What is that doing? So let's see. V dot W. We did this a minute ago. 2 times 5 is 10. 2 times 3 is 6. That's 16, right? We did that a minute ago. So there's the dot product. Cool. What's the length of vector W? We did this a minute ago too, except for I changed its name just now. That would be W is 5 and 2, so that'd be 25 and 4. That's the square root of 29, right? That's it. That's all we need. We're done. Okay, so what's the projection of vector V onto vector W? It is the dot product, 16, divided by, notice, what are you doing to that square root of 29 there? What's the formula say?
You're squaring it, so you're just kind of getting rid of the square root.
Exactly. So you're squaring something that was square rooted. So it actually is getting rid of the square root. And so that's just a number. Like you get a number from that, some fraction in this case. And then what are we doing with that? We're multiplying it by vector W. Vector W was 5, 2. What did we say Monday, I think? What did we say? What do you do if you're multiplying a vector by something? What does it mean to multiply a vector by something?
It sort of functions like distributive law.
Yeah, you're just multiplying it in there. Bam, bam. You're kind of functioning. And let's just write this down as decimals. If I'm in my open math, it might want the fractional answer for this, but just so that you can make some sense of it. So I'm taking 16 divided by 29 and I'm multiplying it by 5. When I do that, I get about 2.76. And when I take that 16 divided by 29 times 2, I'm getting about 1.1. Huh? Huh? What? Let's redraw this nice and accurate, and let's see if we can figure out what this means. Over 5 up 2. There's vector W. And then the other one was over 2 up 3. Over 2 up 3, that's this one right here. Bam, there's vector V. There's vector W. And now what's that? Huh? Well, just draw it. That says right 2.76. 1, 2, that'd be 3. So would you agree it's about right there? 2 3/4. And then up 1.1. Up 1.1. Oh, that's weird. I just landed right on vector W. So what do you notice? Oh my gosh. If I connect that down there, that really is 90 degrees. Oh, that's cool. That's literally giving me, it's changing vector V to see how much of it is actually helping out good old W. It's projecting vector V straight down onto W. That's kind of cool. So just so that it's sitting in front of you, copy, paste, your turn. You do this, except for I'm just going to give you totally random vectors. And I'm going to, like, those were nice because they were both in the first quadrant. But let's just, and again, if you have time, draw a picture of this and see if you can see it. It's not, oh my God, that actually worked. That's amazing. So let's go -5, 3. So that puts that in the second quadrant, right? And then let's put the other one, I don't know, down in the third quadrant. So let's put W in the third quadrant. Let's make it -2, -8. Just going to give you enough time to see if you can just plug it into the formula, do the math first, and then see if you can draw a picture of it and go, huh, that's pretty cool. Worked. No, we're working. Just double check, make sure you got the dot product right. I think that answer would be 10 plus -24. That'd be -14, right? So we got a negative answer for the dot product. It's a cool shortcut for a process that would be very painful to try to do kind of by hand. And did you get for vector W that its magnitude is 64 plus 4, which is 68? So and
My answer's in chat, but I'm not sure if it's right. It feels like it should be negative.
Yeah. Yeah, because notice you're taking a negative times a negative, so it ends up as a positive. If my open math annoyingly wanted the answer to be fractions, you'd get that 14 over 68 times 2. And by the way, when I do stuff like that, I'm just cheating on my calculator. Do you type that in and then go to the math button and say convert to a fraction so you don't have to do it yourself? It's not that I can't do fractions, but it's like a boring waste of time. So if I type 14 divided by 68 times 2 and say math convert to a fraction, 7 over 17. But as a decimal, just to kind of write it down. And to Nick's point, if I get positive numbers for that, there's a part of me, it's like, okay, well, I think I plugged all the numbers in right. I mean, I think this is the answer. But again, I'm you talking here, but it's like I only partially understand what I just did. Is that right? Like, what did that just do? I don't. So let's try to draw a picture of that. So let's draw a picture of this. So negative 5, 3. So this is kind of my check. Negative 5, 1, 2, 3, 4, 5, positive 3, positive 3, bam, there's vector. There's vector V, and then vector W is negative 2, negative 8, negative 2, 2, 4, 6, 8. And so just graph the vector, 0.41, 1.65. Let's just graph that. 0.41, well, that's about, like, there'd be 1, so 0.41 is like halfway, right? And then up 1.65, that'd be about right there. You agree with that? Tracking with me there? I went right 0.4, just kind of guessed, a little less than half, and up a little over 1.5, and that put me right there. And so there's vector projection, V onto W. Does that look right? The answer is yeah.
I didn't realize the angle between V and W was greater than 90.
Yeah. Notice, if you will, vector V is not being helpful. Vector V is being not helpful. You see what I'm saying? It's like pulling in the wrong direction. So the cool thing about this from a practical perspective is, what if this was the airplane and what if this was the wind? Does it make sense that projection is actually telling you how much of the wind is actually slowing you down? Now, the wind is also blowing you off course. Does that make sense? We kind of talked about that. It's blowing you off course, but in a sense, this is how much the wind is actually slowing you down. So the wind may be really strong, right? That's a long vector, but it's only the part that's pulling directly against you. In this case, it's actually slowing you down. In the previous problem, it was actually helping you. It was like a tailwind. But that's why you would do this. It's like, how much is actually, participating in what's really happening? The airplane is, people trying to fly someplace. And if you could calculate this number and it's like, oh, I guess that's actually slowing us down by 10 miles an hour, then you could kind of, tell people on the plane, hey, we're going to probably arrive at, 11:15 instead of 11:01 or something like that because of that wind slowing us down. So Do you see that? Do you see the application for it? I mean, this class isn't really a whole lot about applications, but I always kind of feel like as a teacher, if you don't show people a reason that something's worth knowing, then they're not going to learn anything. They're going to be bored to death and, you know, kind of feel like this is pointless. But what you're doing in this class is preparing yourself for advanced math. You know, I mean, that's in a sense what this can do. And so if you take a physics class and you need to know physics, that's where you're going. You know, that's kind of what these classes are really for, is for people that are going to do a job that's STEM, you know, kind of a science math type of a career. And so you can see that if I took some physics, that this kind of knowledge would really come in handy. I could use this for things. So as long as I got the formulas in front of me, this is not terrible, right? But if I don't have the formulas in front of me, this just becomes very terrible. How you doing? You all right?
And I can kind of see how we would solve this previously, like how it would be set up previously. Instead of them both being set from the origin, you'd have B set from the end of W. And then you'd solve it that way, and then you'd be able to see how much it's pushing against.
Mm-hmm. Yeah, there's other ways to get this, but this is the automated way. And again, in this case, it also has advantages and disadvantages. It's amazing because I didn't really have to think that hard. That's really cool. But the disadvantage is, you know, you stare at that formula and think, where did that come from? You know, why? How did you get that? You know, how did you automate that process? I feel like because this class is 2 hours long that I don't think I'm going to show you this, but I will post this for you. This is a sheet I made to explain, for instance, the dot product between a couple of vectors, and more importantly, the angle between a couple of vectors. If you're like, where did that weird formula of cosine and dot product come from? I made what I consider to be a pretty clean explanation for this, way cleaner than what's in a book. This will be in your book someplace, but this is kind of my own explanation. So the only thing I want to say about it is, if you had this vector A over here and this vector B over here, and there's some angle between them, does it make sense that if you draw sort of a vector connecting them, that makes a non-right triangle, and then I could employ law of sines and law of cosines? So I'm just going to at least want to address the overall logic. And if you decide you care, you can look at this a little bit more. But I feel like it's been 2 hours, you know, it's like show them something else. And that's not such a great idea. As I said here, though, it's really kind of interesting. Notice the name of this vector would be B minus A. That's kind of weird. Notice the direction of B minus A and prove that this is correct name for this vector. Would you agree if you went A plus B, isn't that head to tail? So if this was A, I'm trying to draw that roughly the same direction, and this was B, then wouldn't this distance be A plus B? Isn't that right? You reconnect them head to tail. Like, in other words, I started here and I went first to A and then I went to B. And so isn't the shortcut where you add them? But if instead of plus B, you actually went minus B, wouldn't that be exactly the same thing, but in the wrong direction? Then wouldn't this be A minus B? Notice how that vector A minus B looks a awful lot like this one, except for that one's B minus A. So that was actually doing B first. And so anyway, it's not a big deal, but anyway, now I have a name for all, I'll just leave it at this. I now have a name for all three of these sides. This side's, the length is B minus A. This side, the length is A. This side, the length is B. And I know this angle. So does it make sense? That's a law of sines problem now, if you have three sides and one angle. And so the gist of the formula then comes from, and this is brilliant stuff. Now, I didn't make this stuff up. I'm not smart enough to make this stuff up. I just read it and understood it. It's like, wow, who thinks of these things? Like, it's really brilliant for people to come up with formulas like this. So you know, if you write out the law of cosines, so the strength of this is to derive a formula for theta using these two vectors. We find the magnitude of b minus a in two different ways. I found it using the law of sines, and I found it using the dot product. So there's two different ways to write out what the length of that side is, and that's what results in this formula. If you're a person that finds that interesting, then there's some things for you to think about. If you're the kind of person it's like, I'm a week from this class being over, my brain is full, I don't care, you're giving me the formula, I don't care where it comes from, that's okay too. If this is your last math class, I think that's probably a good attitude to have. If you got further to go and you want to understand why things work, like, this is kind of cool. So anyway, I'll post that if you want to stare at it, but you don't need to know that. Okay, I think we've taxed our brains enough, and it's 7:20, so let's call it a day. So I'll get that test all ready to pop up for you. It'll pop up anytime after 8 o'clock Friday, and I'll make sure that this note sheet that I've been referring to is available to you as well. Actually, while I'm thinking about it, why don't we just quickly look and see? I think I may already have this note sheet for you sitting in my Open Math anyway. If I do, then I probably won't repost it. So I think it's in course information. Did I put this in here? Yeah, Doug's formula sheet right there. So I'm not going to repost it. It's in my Open Math. You can either just open it and look at it electronically, or you can print it out. Or the note sheet that, let me see, the note sheet that came with, that I think Matt put in here for you at the start of this class. Let me just see what's on that note sheet at the bottom. So his has the angle formula, the one that we just talked about, the dot product angle between those two, that's sitting there. So that's in there. It doesn't have that projection stuff. There's projection stuff in your assignment, and that projection note is not on his note sheet. There is a problem in your assignment though that talks about work that we didn't talk about, but there's a problem that talks about how work is a force times the distance, and so you might need that for the. But you have both of these note sheets, and you can use these for tests. So I won't repost them. If you're good, later, get out of here. If you want to stay after and ask me questions, do it.
Thank you. Bye.
Thank you.
Later. Thank you all. Appreciate your attention.
Thank you.
Thank you.
I have a question.
Yeah.
Regarding to square rooting.
Uh-huh.
So let's say if I don't, maybe I might share my screen so that it's easier to see.
Sounds good. Do you have the power to do that? Let me see. I'm going to make you a co-host just to make sure you have the power to do that.
Right. Okay. Thank you. So I think it's on double angle identities. Yep, it is. Okay. So let's say if we get a square root like 63, and let's say I didn't reduce it to 3/7. Would I get that wrong in your eyes, or
No,
because I don't know if,
my opinion
Okay.
on that kind of stuff is you should be capable of reducing it. If somebody wants to make you, like my Open Math wants to make you for some reason, then fine, that's okay. But I'm not doing that unless somebody makes me, because it's boring. I'm capable of it, but it's a waste of my time. So no.
right, it's one of these things that I easily forget, and I made this mistake on the first exam. You weren't here yet, but it was Hagen, but I made a mistake. I didn't do it right, and it messed me up on everything. So I
Yeah.
was really mad, and I always forget that. So I was just wanted to run that through with you to see.
Well,
if
that's why I'm a believer in partial credit. Like if your original answer there was say correct, and notice it told you it was correct, and I'm really glad my Open Math did that because it didn't make you simplify it.
Yeah, it didn't. I worked on this with someone, and it took it as square root 63 instead of 3/7 and this other
Yeah.
form. So I was kind of just wondering.
Yeah, notice it's weird how different that looks, isn't it? Isn't that strange how different the answer looks? And so, it's kind of cool to spend some
Yeah.
time and try to see, how it would look if it went in there. And just as a side note, does it make sense if you took that 1/4 and brought it inside? In order to square root it, you'd have to square it. In other words, if it came in, it would have to be 1/16, wouldn't it? Because it would have to be squared to be under a square root. And so then it'd be 1/16. Well, notice 8/16 is a half. That's where the half came from. And then notice the square root of 63 is over 16. So can you see they're the same, even though they actually don't look like it?
Yeah, that's why I
So-
was looking at this. I was like, oh, interesting. And
So that's kind of cool to be able to see, oh, okay, those are actually the same, but
yeah, there's a lot of different forms, and like rounding has been such a pain in these homeworks. I don't know why, but
yeah. So let me give you one piece of advice about that. If a problem says round your answer to 2 decimal places, it's extremely important. And what they mean by that is I'd like the final answer in 2 decimal places, accurate to 2 decimal places. Well, if you do all your work in 2 decimal places, then your final answer is going to be off by more than that. You got to round all your work to 2 to 3 or 4 decimal places and then wait to round to the end. Do you see the logic in that? So that can cause that problem.
Right. Usually when it doesn't tell me, one of the things, if it doesn't tell me that I need a round, I usually just put in the whole thing because I don't know. I'm afraid of messing it up.
Yeah, you're gun shy and you feel like it's gonna get you, if you don't
Yeah.
a little further.
And I know
so.
my open math is so not glitchy. I mean, like so picky. And like an example is for the law of cosines, there was one problem that I think it was, which one was it? I think it was for this one. I think that I had to use one of the problem like on the top, and I couldn't round it for the next problems.
Yeah, see, that's exactly right. Like if you got 10.71 for A and then you proceeded on, then you're going to get B wrong. You got to use 10.712965, more decimal places. So that's kind of what I mean. And that's to me both frustrating and I sort of don't care as a teacher. But if you ever were to use this, it is important to understand if you say, I'd like, I want all these answers to be accurate to 2 places. The only way that happens is if you carry it out more. And so, that's kind of in my opinion, if you got those wrong and, like the last answer, you had 74.37, fine. If the problem on a test is worth 10 points, fine, take 1 point off for me, but I obviously understand it. So take a chill pill, so the problem I have is for your sake, and this is why you're frustrated, is if the question's worth 1 point and they're like wrong, because you got 74.37, well, that's not really fair, right? But of course, that's the downside of a computer. So the fact that it's telling you right or wrong at 11 o'clock at night when I'm in bed is worth something, but it kind of comes at a cost. And so, And one other side note, like if you're doing one of these problems and you run out of tries, and you can send me an email, send me a message in my open math and say, I got this answer for, this question. And it's like, the only reason I was wrong is because of this small thing. Learn from it, and don't let it happen again. But, if it ends up affecting your grade, like you might talk me into that, because if the choice is between 0 and 1 point, getting 0 is like 0%. You're like a super effer. Well, that's not really fair. I mean, if I had to pick between 0 and 1 and you answered 74.37, you deserve 1 more than you deserve 0, right? So that's one of the reasons I put 3 tries on these things, is so you can fix all that dumb stuff. But it's frustrating.
Yeah. And then one more thing. So for something like this, let's say you set it up, let's say it uses the C formula, and you had to find the little c, which is what I call it little c. And can I just put that all in the calculator instead of solving it? Because it still gives me the answer and I get it right. But let's say if I just set it up like all of this, it's all set up in here, and I square root all of it.
Yeah, you just type the square root of all this gobbledygook and don't even simplify it. Yeah, absolutely.
Instead of solving for each step, can I just put it all in the calculator and get my answer?
Absolutely, you can. Yeah.
Okay. I don't know if you don't like that. I don't know how different teachers wanting us to show our work, or because I just kind of been dumping it in the calculator whenever it gives me, whenever
Good for
it's set
you.
up like that.
Yeah. In an earlier algebra class like math 95 or 65 or something, where it was important to kind of show you understood the order of operations. But again, you're 1 week from never doing algebra again. So these kind of shortcuts, you should be typing all that in the way you said it. In my opinion, you should get a high five for that, because you know that if you did type them in one step at a time, you probably would write something down wrong. Like calculator says 71 and you accidentally write down 17. Like you open yourself up for stupid mistakes the more steps you make out of it. So no, this class is beyond that. In other words, you should be easy for you to plug all those things in. And so we're not testing that anymore. We're just testing, can you get the right answer for that thing? So no.
Right. Okay. That's what I was curious of. So far, I'm doing okay. The only ones that were very at first, vectors was doing just fine in the beginning, and then towards the end, my brain wanted to kill me. I was like, what are these problems? They were, I went through them and I got them done only because I got help on it, and it was so difficult. It made every other problem so much more easier.
Yeah, it's pretty deep water. You know, we're doing some
Yeah, well, this
crazy
is my
stuff
last
now. So
class, so I'm just trying to pull through. And
yeah, absolutely. What's your grade right now?
what is it? It's like a high B, I think, which I'm really surprised at.
I'm actually
Yeah.
looking since I can. Yeah, 87%, 87.7. Yeah. Yeah. I mean, you're sort of home free, I'd say, you know, I mean, you still got a test and a final, but I'd say you're sort of pretty safe to keep a B, and you might even get an A, like you're right there. So
I don't mind either or, honestly.
yeah,
but
yeah, absolutely. So you should feel good about that. You know, good for you. That's no joke to do that. Good for you.
yeah, no, I'm trying to get at least a B or an A. Either or is totally fine.
Yeah.
But yeah, okay.
I can
Well,
tell you're a hard worker and you care a lot about your work, which is worth a lot in the real world. So good for
Yeah.
you. Good for you.
Oh, and one more thing is for the last test. Well, since there's no review for that, are you making a review for the cumulative test?
Yes, I am. I'm probably gonna give you a paper test for that. Send it to you. I got to think about that, but we have Monday to review, and so I'll sort that business out this weekend and get something for you there. But I will have a review for you.
Will it be like kind of like the reviews that Hagen set up, like in my Open Math, where it's like 30 something questions, or is it different?
Yeah, good question. If I decide to give you a paper test, then I'm going to give you my paper review. If I decide to give you a smattering of all the other tests that you've given, then I'll probably just have you do my Open Math review. In other words, you don't even really need a new one. If it's the same questions I'm going to draw, you'll have had 3 tests. And if I'm just going to draw the same questions out of those 3, then we can just use that review. So I have kind of mixed feelings about that. I don't necessarily want to switch things up. And if I give you a paper test, like it might sort of feel harder to you or different. But I also feel like that's kind of the important thing. So I haven't decided actually.
Yeah, at least I try to do I always try to do the reviews that are given to us, even though I know it's more than more questions in the test, but I still do them. It's